So I'm Patrick, and this is really meant to be a hands-on, practical, how do I actually use this thing type talk. We're not going to cover research or any kind of groundbreaking new stuff. This is more about how do you be a Claude Code power user, that sort of level. How do we take these AI, LLM things that we've heard so much news about and actually use them to do something practical, use them to write useful software? So the plan is, why agents? What is an agent? And how did LLMs kind of change the game? Then we'll move on to how do you build one, which will cover deployment, prompts, tools, and skills. And then we'll do a dive into one that I actually built for the sake of this talk. And then we'll cover how do you get started, and if we have time, go into some advanced topics. So why agents? Well, people are interested in agents, and in the wild they do all sorts of stuff. Claude Code is a very successful agent. There's agents that do auto research. Zoom in even more. Is that better? That's good. Yeah, thanks, Lizzie. So, there's agents that run customer support desks now. So that's kind of cool. And obviously, like the whole PA type agent is a big use case. And there's kind of this gap. You learn about AI, you open up ChatGPT or Claude or whatever, and you start talking to it. It's kind of cool. You can get back code. You can generate images. But you want it to do stuff. So really what I'm trying to do at the end of this talk is equip you to make these AI things do things. So let's dive in. This is some theory. What is an agent? And there's actually a definition of agent in a book called AI, A Modern Approach. An agent is anything that can be viewed as perceiving its environment through senses and acting upon that environment through actuators. This was written in 1995, I believe. So this predates LLM by a long while. And they have like this handy diagram here. This is Claude here. This is ChatGPT. This is Kimi. But that's not the agent. The agent is the box. So another name for this box in the middle is called policy. Policies turn percepts into actions. And lots of things can be regarded as agents. You don't need to have an LLM. A thermostat is an agent. The percept is the current temperature, and the action is turning on or off the heat. AlphaGo is an agent. The percept is the state of the Go board. The action is the next Go move. A self-driving car is an agent. The percept is LiDAR. The action is the steering wheel and pedals. But I think there has been a little bit of a change. In kind of a modern deployment, we'll talk about agents being an LLM tools a loop in an environment. So, here's like a little bit of a decoder ring. The LLM and the prompt is the policy, which figures out what to do next. The tools, sensors, and actuators. The loop is like and then the environment is where does it run and what can it see? And we'll kind of cover more on that. Another bit of theory before we move into LLMs more is agents are on an autonomy spectrum where you can we want to be here, if we can, fully autonomous agents. But when starting out, you kind of want to be here. And we'll discuss some reasons for that. So agents have been around forever. But how did LLMs change the game? And kind of what changed is there's been a couple of errors. So like the old AI era was like this expert systems rules, if then rules world. And that was kind of good, but it didn't really scale. And then we kind of had something better, which was classical planning. And a great example of a classical planning agent is an airline scheduler, where, you know, the percepts in that case are what airlines are coming in and flying out of the airport, and the action is which airplanes do we schedule to take off next. And that worked really well because it was a fairly limited domain, and you could formalize this concept of takeoffs and landings and runways and occupation and so forth. And then the next era was RL, or reinforcement learning, which was really cool. And this is what was used to build ChatGPT. And the only downside with reinforcement learning is that you have to define what good looks like. And it's kind of, everything's kind of set up to one specific use case. So one game, one robot, and it doesn't really generalize. So I think the big thing that changed is this paper called Tool Former. Language models can teach themselves to use tools. And I think this is kind of the big thing beyond ChatGPT that really changed the game for, you know, Kimmies and so forth. The difference between something like Claude Fable versus ChatGPT is that Claude Fable has a tools section. Claude Fable, living in Claude code, can write stuff. It can search the web. And that's because there's actually been research in how to train LLMs to use basically any tool that we can describe. So, you know, this is published in 2024. There's been 2 years of research, maybe closer to 3, because this is not the preprint. This is the official release. So there's been 208 years of AI research on tool use, and that's where agents kind of come in. So what this means is that rather than learning a policy, really what we want to do, you know, you see this diagram, right? Your attention goes here to that question mark. You think, oh, I've got to build a policy. You know, I understand what sensors are. I understand what we can do. I need to figure out how to go from here to here. But these days, actually, this question mark is replaced with your favorite agent harness. Claude Code could just fit in there. Your job is just to describe the percepts and actuators. So how do you build one? And the first thing, which isn't even covered in the above diagram, like maybe arguably it's in the border, is where does the agent live? And please don't tell me it's your laptop. So what you want as just table stakes for an agent is a program running on hardware on a loop somewhere. Or now I know you cloud people are going to say, oh, well, what about serverless event-based stuff? You know, there's still a loop coordinating that stuff. But you want to, so like the simplest way you can achieve this is cron. For those of you who don't know what cron is a Unix utility that lets you schedule a task to be run every hour, every day, every 3 minutes, whatever it is. So you take your prompt, you add cron, now you've got an agent. Now you've got a loop. And deployment is an environment choice. So what I've done here for this talk, which we'll go into, is I've used GitHub Actions for my deployment. So what that buys me is a few things. Number one, GitHub Actions is cheap. It's actually free. Number two, GitHub handles all the admin for me. And number three, GitHub Actions plugs into GitHub, and I want my agent to talk to GitHub. So it was a good choice for this talk, but obviously where your agent lives, it doesn't have to be GitHub Actions. It can be anywhere, but that's kind of where you want to get good at a little bit of, I think the phrase is DevOps or cloud engineering or operations, quote unquote IT. You want to know where your programs are running and pay a little bit of attention to that. So here's the GitHub Actions for my agent. We go run Claude code, and the actual code is written for me, but I do need two things. I need a GitHub token and I need an Anthropic API key. So to get that, you have to go to platform.claude.com, which is different to Claude.ai. And you have to, you can see how much I've been spending money getting this agent set up, but you have to build an API key. You have to buy one of these things. You have to copy and paste. So yeah, deployment. Then of course, as you know, agents LLMs get prompted. The one thing I do want to say with prompts is that prompts can double as your perceptor, in the sense that you can take whatever information you want your agent to know and paste that into the prompt. And then either side, you give it instructions for how to deal with it. So you can have like the goal, the standing instructions, and then the specific task information. And ideally, just a little bit of prompt engineering advice. You want to have what in the world of software is called the definition of done, which is how do you know when we're done? What does good look like? This is not just advice for dealing with agents, by the way. Whenever you delegate something to somebody, you should provide a definition of done. Also, when you delegate to an agent, you should provide a definition of done. And then finally, tools. This is like this concept of actuators. Anthropic published this concept of the Model Context Protocol, which gives a series of tools that LLMs can use with corresponding permissions. So tools like read or edit or bash are really handy. And MCP is kind of a standard for publishing your own tools. So there's a tool for connecting to GitHub, a tool for connecting to Slack, Postgres. It's really, really easy if you have an API to turn that into MCP. And that's how you plug things into your AI, basically. That's how you give your AI a new limb to do new stuff. And finally, there's this concept of permissions, and this tweet, and sorry Lizzie, I'm going to have to zoom out a little for this tweet, is why you need permissions. So I'll read this tweet out loud. This AI agent had God mode permissions and deleted the database. Now, this is why you need a permission system and why the agent can't live in your laptop. Because your laptop has God mode permissions. Your laptop has access to your credit card. Your laptop has access to all your SSH keys. My GitHub Actions thing can't delete my production database because it doesn't have the credentials to do so. It can't even update this repo. It can just raise a PR. So this is this concept, in the world of security, this is called the principle of least privilege. You want to narrow the permission. You want to give enough permissions to do its job, but no more than that. You want to give as few permissions as possible that still allow successful execution. Sometimes in IT, there's something I call the principle of less than least privilege, which is you don't get any permissions until you file a ticket. I don't believe in that principle, but I do believe in the principle of least privilege. So practically, what does this look like? Well, there's actually two layers of permissions here. One is the GitHub Actions layer, where GitHub can edit contents, make pull requests, and read issues. And also the Claude layer, where I've given it the ability to run tests and create PRs. And if it's not on that list, the agent can't do it. So note in here, I did not give it permission to spend my money. I did not give it permission to delete the production database. I didn't give it permission to upload my SSH key or read the SSH key. So, you know, I think it's kind of a testament to our state of IT that Markdown is now an attack surface. But that's the world we live in. And then finally, another way to do actuators is this concept of skills. And this is the equivalent of functions in programming. A skill is a procedure that the agent loads when the task calls for it. So, you know, here's an example skill, which is just a checklist of things to do to make a PR. And skills can actually get quite complicated. Skills can involve your own programming. By the way, a rule of IT project, a rule of AI projects, never use AI to do something that can be done without AI. Because anything that can be done without AI is a lot cheaper, a lot easier to debug, and has less legal issues. The government won't attack you won't regulate you quite so much for using a Python script as it will for using an agent. But yeah, so use Python when you can, but you can wrap that whole Python thing inside a skill for how to use it. So, you know, this is common, I find, in a lot of DevOps cases where you have this idea of a run book, but there's one or two environment variables that you need to change. Has anyone encountered that, where you have like a description that's 90% done, but there's a few things where you have to go insert API key here, insert client name here, and then the task runs successfully? That's, yeah, I think Adam's encountered that. That's perfect fodder for a skill, because the AI can just fill in that gap for you. So I use that at work a lot, where I need to push for a particular client. I'll just say, run the deploy model skill for this ID. And I'll be like, run it again. And it'll know what to do, and so forth. So that's kind of cool. So skills can have complicated directory structure, And skills also have various metadata. This is really the only metadata that's required. This is kind of helpful, the descriptions side of things. And then ideally you would have like an allowed tools which tells you what permissions are you allowed to use when executing this skill. So what does this look like? I have a GitHub repo. I have an agent connected to this repo. I have an issue. I have like some source code that computes the median of a list. And it's terrible because it doesn't get the median of this list right. It should be 2.5. So I filed an issue. My agent read that issue description, came up with a code change, and made a PR. I can now review the PR and either accept or reject it. And I'm going to approve. And there we go. This is the secret world of engineering management, software engineering management. So yeah, that's my agent in action. We can write a new one. Write a standard deviation function. Write a function that calculates the standard deviation of a list. Create at Claude, make it happen. Now, this is where I really hope this works. There we go. Longest minute of my life, but this is a Claude code now running its agent loop, where it'll get this function and it'll figure out what's going on. So we'll check in with Claude a little bit later. Sorry? So I did. Funsaton. Yeah. So I know in programming, one of the hardest bits of programming is syntax errors, where you make typos. And allegedly AI solves this for me. So I'm hoping to see what Claude will do with my fat fingers.
I think you finished now.
It's finished already, has it? Oh, no, it's still going. It's just read the issue. So going back to the talk, apologies, should have added a table of contents and my Claude MD instructions. It locates the file, edits the file, runs some tests, runs a commit and pushes the branch. And I actually think this guy's going to fail on my issue because I didn't give it the right permissions. The principle of less than least privilege. And this is all tool calls. I screwed up. I need to give my agent another limb, which is the ability to write files as well as read them, but we'll come back to that later. So, just to cover what we did, the deployment of my agent was GitHub Actions. The prompt is a combination of the issue description and Claude.md. Our tools, we've got read, grep, edit, shell, git, and GitHub. The permissions is it can open a PR, but it can't merge to the repo. And it can't go crazy with the, it can't call, some Russian website and start mining Bitcoin. And we have this idea of the verification, the definition of done, Pixie run test. So how do you get started writing your own agents? And one of the hardest things about preparing this talk was actually coming up with a fun demo use case. A lot of the material deals with agents kind of in abstractions. You know, you'll automate your business processes. You'll achieve production synergy. And it's like, well, what do you want me to do? So think about this seriously. And really the skill here is a lot less about traditional ML skills of policy gradients, tensors, causality, all that. It's more about product design, imagining a good solution, defining the problem. And so what we covered today is we have like a definition of done, we have a step-by-step procedure, we have a scope of authority, and some sort of escalation path. And one thing I hope you'll take away from this talk is you don't actually need to program to do any of this stuff. You just have to think like a programmer. So if you already have checklists, runbooks, onboarding docs, standard operating procedures, it's very easy to turn these into skills and turn it into an agent. If you kind of already have instructions on how the work gets done, most of the agent already exists. It's just, you just need to deploy it somewhere. So where do I learn more? Can I have a time check? Where are we on time?
We've got tons of time.
We've got tons of time, great. So what I'd like to do now before we get into the advanced stuff is just do a little bit more of a deep dive into this repo. In particular, we've got this Claude.md guy. So Claude.md is instructions for Claude code. And what you want to, you can get Claude to help you write this, but really what this does is it's a series of instructions that are loaded every time Claude runs. Do I need to zoom in a bit more? Yeah. So, you know, so you want to give it like just general advice for working in this repo. This is like your onboarding doc. And then for my Claude in particular, I wrote this skill called Pixie, because Pixie is the way I like to write Python code. Python has like 7 different virtual environment managers. Pixie is the one I like because it's compatible with Conda, which exports all the nice data science stuff. And it just gives a cheat sheet for how to use Pixie. So again, this is a skill that Claude can access. Again, it's just 90%, it's all markdown. You just need to have like a couple of commands here and there. Claude will pick it up. And then I have this settings file, which is a way of defining the permissions of your agent. And this doesn't have to be limited to your agents. You can have, I would encourage you to have settings files for your software projects as well on your laptop. And that tells Claude what it can and can't do. So what you want to do is, you don't want to have bash star as a permission, for example. That would be an overly permissive environment. But you might want to have like bash Python star or bash Pixie star. And then I have like this concept of the GitHub workflow. Is this new to everybody? Has anyone made a GitHub action before? A couple of people? Well, if it's all right, I might talk about this a little bit, just because I'm hoping, who here's used GitHub before? Yeah, a lot more hands on the GitHub. So GitHub Actions are a way of triggering a piece of code to run when a particular GitHub event occurs. So in this case, the trigger is that there's an issue comment and an issue being run, and Claude has actually, so that's the event. And then that kicks off a job called Claude. And the first thing Claude does is check if anybody mentioned Claude. If not, the job finishes in a second. No Claude for you. Then you can define this runs on guy, which is where you want, this is like the computer that the action will run on. And then you define the permissions of the job, and then you have like a sequence of steps. And a lot of these steps are pre-built things, but you can also just run bash as one of the steps. So here I've got a couple of boilerplate steps: check out the code, set up Pixie, run Claude code. And each of these steps is actually defined by somebody else. So there's a action published by GitHub called the checkout action. Let's see, GitHub Actions, checkout. So it's kind of like MCP, but for GitHub. So this will like let you check out repositories. And the idea is that you're sort of defining the steps in sequence. So if you do have a GitHub repository, I'd strongly suggest checking out GitHub Actions. It is free. You get about 2,000 to 3,000 minutes of runtime just as part of your subscription for free. So you can have an action that, say, runs tests every time you make a branch, or you can play around with Claude Code if you like, or do whatever, do whatever else code things you want to do. And then for the Claude Code action in particular, which is a fun way to actually get started with Claude as an agent, you do need the Anthropic API key, which is the thing that allows you to actually use Claude. It authenticates to the APIs, so somebody has to pay for it. So that's what this API key is for. And that lives in the GitHub repo. That's a secret. You don't want this API key in plain text. And then there's an argument where you can Claude args. So one thing you can do in the terminal is, sorry. There we go. Claude actually has the ability to not run with the prompt. So you can go like Claude P, how are you? There we go. And I'll do a bunch of permission stuff and fail spectacularly. I might need to go to another, there we go. So now Claude is over. And the point is that can be invoked from a script. But the other setting that's interesting is tools. So you can tell, because we got a bunch of warnings here saying, hey, you're not allowed to edit, you're not allowed to do write over here. So you can use the tools argument to actually give Claude permissions to do things.
Can I ask a question?
Yeah, please.
Could you go into like how you decide what you make as a skill as opposed to kind of just letting Claude know, like the stuff Claude knows how to do?
When do you write a skill?
Yeah.
Yeah. So I would say that it's sort of like when do you write a function in programming versus when do you just use boilerplate. So I think the typical rule of thumb is the rule of 3. If you find yourself doing the same thing 3 times or more, then, on the 3rd or 4th time, that's when you'd want to start to abstract away. So I would make liberal use of skills if you have the time. And certainly I think if it's something that you do repeatedly, it should be its own skill.
Is that mainly so that it's more deterministic or more like debuggable?
Yeah, it's more debuggable. You get a level of consistency. You know how sometimes when you want to do things, there's a bit of context that you might forget to specify in one chat session versus another. So skills can be a great just library of context for that too. So, if you have something involving multiple steps, writing that as a skill rather than 3 separate prompts just saves you a bit of time. So Claude can just execute the skill and then you go make T. So I would make liberal use of skills if you can, but obviously, like with functions, it's a little bit of a judgment call around how early do you abstract. It's like brushing your teeth or eating your vegetables. It's something everyone should make use of abstractions, but you should do a lot of things. So. Does anyone else have any questions? Feel free to interrupt me with questions at any time, by the way. Yeah?
Earlier you mentioned somewhat in passing that you don't need to be a programmer to use these tools, but it helps to think like a programmer.
Yeah.
What does that mean?
What does thinking like a programmer mean? That's a great question. So I think the 2 kind of meta skills I find are helpful with programming are defining the end state in terms of artifacts of like, I'm taking this input and returning this output, and also being able to give a series of step-by-step instructions. So an example of thinking like a programmer, which isn't programming, is a good baking recipe. A good recipe will say, you start with these ingredients and you perform these steps. And at the end, you'll get a meal that looks like this. So that would be thinking like a programmer. And then the other side of that, of course, is thinking like a IT guy or IT person, which is where is everything, on what hardware or where do things actually run? And having some sense of that and how much it costs and so forth. All right, back to the talk. So do people feel like they have a sense of what agents are now? Awesome. So now we're going to go into the advanced topics. Apologies. So when we want to kind of go beyond the demo, a really good place to start is this concept of a workflow. And there's lots of different tools for managing workflows, but you kind of want to just say, what are the different steps involved? And each step in this graph is a skill. So, and then you have like the workflow which coordinates the whole thing as like a meta skill. Or a workflow in your favorite workflow management system, such as Airflow, Make, GitHub Actions, whatever else. So so the idea with that deterministic workflow is that the workflow itself is deterministic, but the steps involve running an LLM with a skill to perform a particular task and then handing it over to the next step. So in this example, you read the issues, you fix, you have an agent to verify the skill, and then you have another agent to build a report. And another huge bit of advice, and this is much more engineering specific, is use logging, use UUIDs everywhere. You want to be able to refer to things. You want to say, this version of the model ran at this time with this prompt. Here it is. Here's a link to it, so your support staff can help you debug it. And that's a lot easier when you have IDs that are going into some sort of logging system. So for example, with GitHub Actions, every time an action runs, and I'll show you an example of my actions screwing up, is every time an action runs, we get a corresponding number. So this is action run 13, 12, etc. So I can say action number 3 was the one that screwed up.
I have a question.
Yeah.
Why using this way to workflow in GitHub? And about the cost for each request for the actions. Because you have a cost, yeah? You have a specific number of requests you can do at GitHub action.
Yeah. Yeah.
And each one of these calls are doing out on one request or on many requests for the agent.
That would depend on the action configuration. So an action could do many, many requests at once. It just depends on how you configure the thing in GitHub. You could have like a very complicated loop that runs for an hour or something in GitHub Actions. Yeah. So yeah, logging is important. Cost management is important. That's thinking like a programmer. Another kind of interesting concept with agents that I haven't gone into, but is in Russell and Norvig, is this concept of an agent that learns. So we don't necessarily need to learn anything anymore to start with, but it sounds really good in an investor pitch. And you probably do want to have some, and if it's important enough, you probably do want some sort of learning loop. So one kind of enhancement you can make to your agents is this idea of the memory database. So Claude Code does this by default now, where it has like a special memory folder where it will store notes to itself. And the only catch here is that you want to review this periodically, because sometimes the memories are no longer relevant. It's like a boomer who tells you the only thing you need to do to get a job is, you show up in person and you extend your hand, and that memory was relevant 40 years ago, but now the job market's changed a little. There's a different process in place. So it's like that with memory as well. the world changes, so curate your memory. Yeah?
What are your thoughts on Markdown as memory versus like vector databases or graph databases?
So the question is, what are my thoughts on Markdown as memory versus vector databases or graph databases? And I think they solve two very different problems. I think a vector database is a really good way of storing a hell of a lot of information in a manner that can be queried by an AI. So if you run Google, for instance, you want a vector database. If you have 3 megabytes of text, Markdown will probably do. So that would be my opinion there. It depends on the size of your data. How much do you want to remember? Same thing for kind of swarms, but this is this idea that agents can talk to other agents. So in theory, my agent could leave a comment which apps Claude, and thereby triggering another loop. And I could actually do that. I could say, look, if you find any issues in this code, file an issue and at Claude, and Claude will file another PR. And have like a self-reinforcing cycle. And one common thing, so two common patterns for kind of multi-agent workflows are fan out. So this is where you have 10 things you want to do, you spawn one agent to handle each thing rather than telling the agent to do 10 things at once. So practically what that could look like is, let's say you give Claude your to-do list. Claude would then sub-spawn 10 processes each to do one item of that to-do list. And then there's this idea of, actor critic or adversarial verification. So you have one thing to generate the solution and then a different agent to verify the solution. Because one thing I've found is that when you're using Claude to write software, and this is like with people too, Claude will encounter a failing test and say, it was like that when I got here. I don't need to worry about that. It's not in scope. Yeah.
Do you reuse a query, like saying that, okay, query 3 did like job A. If I want more of that job, just recall that query and add additional tasks to it?
Sorry, can you say again?
You have queries, right, for every Claude like action, like the data action.
Yeah.
So can you like recall a query and it just goes there and adds to that instead of just doing it all over again?
So can I give Claude the same query twice, or?
Like just use that query.
Cache the result.
Yeah.
Cache the result. Oh, and then rather than have it run again?
Yeah.
Yeah, so caching could be another strategy here. Yeah, that's an interesting one. I think there's pros and cons to that. The con with caching is cache invalidation. So if you want the agent to do something as a result of your query, then if you cache it, then it won't do the thing, it'll just return the cached result. It'll skip the part where it actually does the thing. And it'll just say, here's what I did last time. But you might say, depending on how you use Claude, you'll say, well, no, I want you to do the thing. That's why I sent the query. Don't just tell me what you did last time, do it again. Fresh. So yeah, it just depends on the use case.
Some of these strategies of fan out and adversarial verification, they're already in the Claude code.
That's right, yeah.
So how much do you have to manage this yourself versus?
Look, you don't necessarily have to. I think it's more about, so I think when you're moving to deterministic workflows, that's when these things sort of become more important. So yes, you can do swarms and Claude will do a lot of this for you. The thing to then do with Claude is just tell it, use fan out. And it'll handle the mechanics of saying, oh, I've got this agent over here, I can fan out too. Yeah. So for further reading, there's a few different references I want to give. A lot of these are just like from Claude Code. There's a guide to there's a course called Building Effective Agents, a description of the model context protocol, and kind of a fun course by Hugging Face on context engineering, where it'll learn in detail how to build skills, MCPs, etc. And then, of course, if you want to go back to the basics, read Russell and Norvig. Yep, Adam.
Do you have a QR code for this repo?
Do I have a QR code for this repo? No, I don't. That's a fantastic idea. Hang on.
We can post the link on Meetup, but I'd love to play with this.
Yeah, it's,
Ah, sorry.
the URL bar is right there, but it's so hard to read.
Yeah, sorry. I don't have a QR code right now.
DuckDuckGo, do exclamation mark kill R, space, put the link in. Generate a QR code.
Sorry, what do I do? DuckDuckGo.
On the website, DuckDuckGo.
Ah. Sorry.
Yeah. And then exclamation mark, kill R, space, and then the link.
Oh, cool. All right. So that's here. Sorry. So I go here, QR space link, and there's my QR code. So I will, what am I doing? I'll put this in later, but there we go.
While people are taking pictures, I have another question.
Yeah.
Do you fan out agents or swarm agents? So not all programs with the same persona or like.
Correct.
How would you determine the different kinds of agents, and how do you say what the agent is?
So Anthropic actually has a whole guide on doing this. So there's this idea of sub-agents, where you can have a bunch of front matter for, basically it's similar to skills. It's just a level up of this agent is, say, a security reviewer, and that security reviewer would have access to like an OWASP skill or something. So you can have like agent front matter, each with its own claw.md, etc. And then your sort of main agent will know about the sub-agents. Are there any other questions? Yep.
Yeah, I feel like a big important piece of this agent loop is that the task any agent works on is somewhat defined, but I'm just curious what you think, how well defined a task needs to be before you can agent define it.
How well defined does a task need to be before an agent can do it? I think the question is more, what are the consequences of the agent screwing it up? So you don't necessarily want your success criteria to be well defined, but you want your permissions boundary and review procedures to be well defined, I would say.
You did say that the done condition was a very important part of it.
Yeah, I mean, it's important in the sense that it increases the probability of success, but you don't need to do it. It's like brushing your teeth, you know? You start with a crappy description, you fail, and then you come up with a better description.
Thanks. I've been really interested in the model fusion patterns and that sort of thing. Have you found any of that delivers you like a better result than just using one model?
Model fusion patterns.
Like you get one model to write a design, you get another to predict. That sort of stuff.
Right, so the idea here is we've got a workflow and we want different models to handle different steps of the workflow. I mean, I think the biggest practical case I can see for that is speed. So, I mean, I'm fairly new on my journey, but I don't want to maintain 3 different APIs, keys. So what I will say is, like, you can use, like, say, Fable or Opus for your main loop, and then when you need it to do something, that's when it switches to Sonnet or Haiku. Not necessarily because it'll do a better job, but because it'll do a faster and cheaper job, and it has all the context it needs such that you don't need the horsepower of a Fable to get it done. So I think that's a really good use case for model fusion. If you can do it, then you use the cheap agent, and then if you don't know what done looks like, then that's when you use the hard agents for like design stuff, and then the cheap agents for execution. So that's a pattern I've found works pretty well. Yep.
So your agent that you had run off and write you a standard deviation function.
Yeah.
Are you expecting it to tell you that exists in the standard library? Just use that, or are you
No, I actually don't know. Let's see what it came back with. I'm actually kind of curious now. Oh, gee. No, it just wrote its own. Maybe it should have said just use the
Probably.
yeah. Although to be fair, I don't have NumPy on this environment, so
No,
it's in the standard library?
It's in math.
Oh,
Yeah.
I didn't know that. Okay. Now I know.
Which is kind of awesome that it's going and writing in the scope one for the...
Yeah.
I don't understand what the difference between a tool and a skill.
What's a tool versus what's a skill? Tools have keys. So less flippantly, a tool is a method of doing things for which there exists some side, for which Claude can be granted permissions, for which your agent can be granted permissions. So an example would be editing a file is a tool. You can write a skill to tell you how to edit a file, but you actually need permission to go to a particular folder and edit the files. So if you need permissions, if you don't just want anything to do it, if it's more than just writing, that's what a tool is for. So an example of a tool, anything that costs money should be a tool. Anything that makes people unhappy should be a tool. But usually most things you would write day to day would be skills. Because hopefully most of the things that you want to build don't need keys.
And if you wanted to have access like a standard function for
That would be a skill, yeah. That would be you're allowed to edit the requirement. You're allowed to install packages. So you would have a tool to install the package, and then a skill to say, here's a list of functions that are already. Here's a list of popular data science libraries.
So in this case, would GitHub, like would the repository be a tool?
Yeah, the GitHub stuff is a tool. So I can show you what that looks like in my settings.json, I believe. I hope. So I've got Claude settings.json. Oh, sorry. I thought I had this. Yeah, that there are tools for GitHub in particular. I'm really sorry. I thought this must have been an old one. Yeah. Oh, no. Sorry. No, there is a tool in particular for GitHub Actions. Yeah. Yeah, like there's a GitHub Actions, GitHub MCP guy that tells you things like make a pull request. I think the way I did it is I just used the bash tool and let it invoke GitHub directly. But there is a tool specifically for GitHub as well, which probably would have been better to use.
One more question.
Yeah. Okay. Any last questions? Yep.
OpenClaw.
OpenClaw.
About that.
OpenClaw, sure thing. So OpenClaw is, so I'll just get this up on my laptop so we know what we're talking about. The thing that's scary to me in this headline runs on your machine. I don't like things that run on my machine. So OpenClaw is a very interesting idea where I would say what we're doing with OpenClaw as a philosophy is we're ditching the permission system in favor of environment. It's up to the environment in OpenClaw to enforce any kind of permissions. So you have OpenClaw, you give it somewhere to run, it can do whatever it wants within that sandbox, and you don't give it your bank account. And then I think you're in good, you don't let it do anything that would cause you big reputational damage, and I think you're okay. I think it's more of a, I'm sorry, I think I keep coming back to that Claude deleted my production database thing. Sorry, Replit deleted my production database. I shouldn't slander Claude. But I think it's a very interesting concept, and it certainly laid the groundwork for a lot of this agent stuff that I talked about. What I would say, though, is probably don't give it the keys out of the box.
Yeah, I can recommend another one called Hermes Agent.
Hermes Agent, okay.
Much better protection, and also I run it on a VPS, so it's not a market.
Yeah, don't run it, never run run AI on your machine, but don't run AI unsupervised on your machine, I would say. Cool. Let's go to the pub.
Yeah, pub quiz, where are we going? You remember?
Here's
8